Welcome to Programming in Modern C++. We are in week 7 and we are going to discuss module 35. In the last module, we concluded the 3-part discussion on typecasting in C and C++, and in the last module we particularly discussed the very important casting for polymorphic type by dynamic cast, the type ID operator and the required runtime type information system. In the present module, we are going to discuss about multiple inheritance. We have mentioned about it from time to time occasionally, but now that we are empowered with the complete knowledge of polymorphism, particularly the runtime type detection, the dynamic typing and so on a polymorphic class hierarchy, we are able to handle multiple inheritance. So, we will introduce the notion and see what are the consequences of that and how does C++ empower us to handle those. The outline is given here, which will be on the left all the time. So, what is multiple inheritance? As the name suggests, multiple inheritance is occurring when in a hierarchy a class has more than one base classes, more than one classes that it is specializing from. So, consider the case of students, faculty and the teaching assistant. TA stands for teaching assistant. Now, what is the role of a teaching assistant? Teaching assistant necessarily is a student. So, that justifies this specialization. The teaching assistant has a roll number, has a year of enrollment, course of study and so on. At the same time, the teaching assistant is evaluating the different assignments in the courses, they are taking part in the class tests, maybe setting some of the question papers for students and so on. So, the teaching assistant is actually also playing certain roles that the faculty would normally play. A teaching assistant occasionally may even deliver a few special lectures. So, when we have to model this, we have a base class student, a base class faculty, and when we show this inheritance, we will have to put both these base classes on the inheritance line. So, public student and public faculty, the derived class will inherit from both of them. That is the basic idea of multiple inheritance. We can see a refinement of this idea, say in the scenario of employees and managers and directors and managing directors. So, let us look at if we have employees who are managers and who are directors, each one of them is an employee in some way, right. It is obligated to the company, gets salary and so on and so forth. Now, one or more specific persons could be managing director. So, he or she is a manager, at the same time is a director, manager in the role that he or she disburses, director in the way that sitting in the board of the company deciding on strategic matters and so on and so forth. So, here we see two different things coming out. One is at this point we have a multiple inheritance. Now, when it inherits from two base classes manager and director, they in turn actually inherit from a common base class. That is, the whole inheritance hierarchy has one root only, which normally is what we have seen in the case of single multi-level inheritance. But at this point I have a multiple inheritance. So, what I get is actually what is known as a diamond hierarchy. So, we get this kind of a diamond structure. So, we say this is a diamond hierarchy, where I am multiply inheriting from 2 or more base classes, which in turn has a common base class inheriting from. So, naturally the one question that would come up strongly here is in the managing director, what is the identity of the employee? Is the identity flowing through this path of inheritance, or is the identity flowing through this path of inheritance? We will see what are the consequences of that, but this is just the basic definition of what is the diamond hierarchy, or often called the diamond problem also. So, manager inherits all properties of employee, director does so, managing director does for both, and managing director by transitivity get all the properties and operations of the employee, right. Let us move on. So, let me now with a abstract example show you the basic rules of multiple inheritance. What is the semantics? So, we have 2 base classes, base 1 and base 2, and a derived class which is inheriting from both of them. Inheritance, as we have observed, is public, and that is what we will continue to use, but it is possible that one or more of these multiple inheritances could be private as well, right. They may be mixed in any way, but usually as the inheritance always tell us that it is public inheritance. So, the basic rules, naturally these rules are extensions and in some cases modifications of the rules for single inheritance. So, what we have is naturally the derived class inherits all data members now of all base classes, because there is more than one base class and it can add its own, that part remains same, quite obvious. It inherits all member functions of all base classes. It can override a member function by redefining it with the same signature. It can overload the member function of any base class by redefining it with the same name, but different signature. So, all these were already there. Now, it can be done for all the base classes of a class that it is multiply inheriting from. Access specifications remain the same, that is the derived class cannot access the members of the base class which are private, but it can access the members of the base class which are protected. For construction of the derived class, it must first call all constructors of all base classes. Right. Earlier there was only one base class, so it had to construct that. Now, it is quite obvious that there are multiple base classes. So, all of those constructors of the base classes must be called, and the base instances have to be created within the object before the base derived class can be constructed. And these constructors will be called in the order in which they are listed on the inheritance listing list that we provide. The destructors, as usual, will be called, all of them will have to be called for the base as well, and they will be called by the same rule that the destructor will be, that destructor will be called first, whose constructor was called last. Right. So, we will proceed in that manner. These are the basic laying down rules. Now, let us look each one of these categories of items one by one. So, we first focus on the data members and the object layout. We have studied the object layout for inherited objects for simple inheritance. So, it will inherit all data members of all base classes, can add members, we have talked of. The layout contains instances of each base class. There are multiple base classes. Earlier there was one, so instance of that was there. Now, all of them will have to be there. And then it will also have the layout of its own class. Now, C++ unfortunately does not guarantee the relative position of the base class instances and the derived class member. It does not say that first base class instance, second base class instance, and so on, then the derived class instance, this will be followed. It may be that derived class instance might come somewhere in between them. It is implementation dependent feature. So, always while we should not normally need to look inside the layout, but when we think about it, we should not think about any particular order in which they will happen. Only thing is every instance of a base class will be together. So, here is an example. I have a base class base 1 which has two data members, int data members I underscore and data underscore. Base 2 has another base class which has two data members j underscore and data underscore, and derived class derives from both of them and multiple inheritance and adds its own member. So, if I have a base class 1 instance, it will have clearly I and data. If I have base class 2 instance, it will have j and data. And if we have derived class instance, it will have a base 1 instance, it will have a base 2 instance, and it will have its own data members. Now, this relative order is, as I said, is not known in general, is not specified in general. The compiler will decide that. Now, the interesting factor to note here is there are two data members coming from two base classes, both of whose name is data. So, as a derived class object, how do we refer to this data member? Right? So, what the data member has to do, what the derived class has to do, the derived class object has to do is to qualify the which data member it wants to access. So, it cannot just access it as data underscore, this one it will have to access as base 1 colon colon data underscore, and this as base 2 colon colon data underscore. This is the added complication that comes up because you have multiple base classes, and obviously they can have members which are common in the name, but they are actually instance wise they are distinct, and both of them will exist in the derived class object. Let us move on to the member functions. So, how does the override and overloads work? Naturally, all member functions of all base classes are inherited. They can be overwritten, they can be overloaded by redefinition. Static member functions are not inherited, as you know. So, there is nothing special in terms of multiple inheritance here, neither does for the friend functions. So, we will not have any other special discussion about them, because as you know that they have no role in the inheritance process, because they are all statically bound. Let us look at an example. We have base 1, we have base 2, and we have derived class which derives from these two base classes. Base 1 has two methods f and g, and base 2 has one method h. Okay. Now, let us look at in view of this, let us look at what the derived class is doing. It has put an f which has the same signature as base 1 colon colon f, the int signature. So, it is actually inheriting and then overriding the function. Right? It has not put any definition for signature for g. So, it simply inherits base 1 colon colon g. It inherits h from base 2, but changes the signature to string. So, it is overloading base 2 colon colon h, and it has added a new member function e. Right? So, this example looks very similar to the earlier one, except in that all these member functions were in the same base class. Now, they are in two different base classes. So, in view of this, if I look at a possible derived class object C, I have not given the details of population of data members and execution, those are not really important here. We are just looking at the function binding. So, C dot f will be naturally base 1 colon colon f, because you are doing a static binding. C dot g will be base colon colon base 1 colon colon g, because you have just inherited it. Here you have got it from derived. So, you have the overridden function which you will be able to call. Here it is the same. If you call C dot H with a string, you will get the derived class H function. You have overloaded. So, in that process you have also hidden the base 2 colon colon H int, right, we have seen, and if we have to make it expose it, we can use the using function, we will soon using feature we can immediately see, and naturally the added member function can always be invoked. So, this is the basic extension of the simple rules that we had earlier, and we can make use of them to decide which function will be called on which different object. Now, let me complicate this example. There is a mental line here. On the left, I show how the base classes may have different members, so that your whole resolution process may get confused. What we did in the last example, though we had two base classes, their member functions were having independent names, but now we assume that they have common names. And if you look at f from base 1 and base 2, they have same signature. If you look at g from base 1 and base 2, they have different signature. Under this scenario, if I look at a derived class object which has inherited from here, I am not talking about any overloading, overriding, anything, just trying to look at the semantics of what do you inherit. Now, if I do C dot f, then the question is which function, base 1 f or base 2 f, which one am I talking of? We do not know. There are both functions have been inherited in the derived. So, the compiler is confused. Similarly, if I do C dot g as 5, then well, you would say that because it is 5, I am possibly using this, but there is some confusion with g as well, because g is also inherited inside the derived. So, in these two cases, will the compiler be able to resolve rightly just based on the fact that the signatures are different. So, you have two g functions in derived which are not overloads in derived, but they are kind of coming in the form of overload from the two bases. Finally, if I have f c dot f 3, we will again have that kind of confusion between base 1 and base 2. These are not kind of exhaustive list, but these are indicative which show you what are the possible confusions that can happen. So, on the right, I try to disambiguate this. I do not change the classes, neither the inheritance, multiple inheritance, but I specify, since I have two f functions, I specify which f function I am going to use. So, I say that I am going to use base 1 colon colon f, which will hide base 2 colon colon f, it will hide this one, it will allow this one. Similarly, I would say that I am going to use the g function of base 2. So, I am going to use this, and therefore, I will hide this one. Right. So, now if I do C dot f, then I will call base 1 colon colon f, because I am using that. If I do C dot g, I will get base 2 colon colon g, because I am using that. The other two functions are hidden, but mind you, they can still be called by fully qualifying with the name of the base class, that if I want to call the function f of base 2, I can still do that by qualifying that function not as f, but as base 2 colon colon f. Same thing I can do for g. You have seen this in terms of the general using the use of using feature here. that is just extended and it takes care of. So, in the design you will have to take care of the fact that if you are having two functions coming from the two base classes which have the same name, you have to make sure which is your default choice for the derived class as an inherited function, and then you can override, overload that as you want. Now, in terms of access specification, it is simple that private members of base classes cannot be accessed, protected members can be accessed by the derived class. There is nothing new. In terms of construction destruction, derived class will inherit all constructors, it should be able to call all constructors, but it may be in a different semantics because it has to build that object inside its own space. It cannot overload a constructor or override a destructor of any base class, you already understand that. In the process, the constructor of the derived class must first call all constructors of all base classes to create the base class instances, and then the derived class instance will be created. They will be called in the listing order I mentioned, and the destructors will be called in the reverse order of construction. So, if we do that, then we have a base 1, the earlier example int I and data, base 2 int j and data here, and I have a multiple inheritance here which adds another member. So, if I construct a base 1 object, I will get something like this. I do a base 2 object, I will get something like this, and if I do a derived object, then I will get this base 1. Why I will get the base 1? Because the x y I have passed to base 1, that is I have explicitly constructed base 1, whereas if you look into this list, this is an important point, needs to be looked at. If you look into this point, the initializer list for the derived class, I have explicitly constructed base 1. I have used the non-default constructor of base 1, whereas I have not mentioned anything for base 2. It will also have to get constructed. So, if I do this, then it is mandatory that the base class that I am not mentioning, the constructor of the base class that I am not mentioning must have a default constructor, otherwise naturally the compiler will give error. For example, in this situation, in this case you could not have written this, say you wanted to write base, you wrote base 2 x y and then k underscore z. If you write this, the compiler will give you an error, because base 1, if you are skipping base 1, then base 1 needs a default constructor which it does not have. Right? So, given that naturally when I construct for this, x y will be used to construct base 1, the base 1 object. The base 2 will be constructed by default 0 0. So, I get the 0 0, and 2 will go to the added data member. So, it will be here. Again, remember that this order and organization is not something that is standard specified. I have just taken one scheme to do it in the order of the base classes, but some compiler might do it in a different manner. You can check out for your compiler what it does. Now, for the same example, let us look at what will be the object lifetime construction destruction. So, now along with the data members, we have also provided the constructor destructor has been provided with cout to actually tell us what is going on. So, when I construct this derived class object, naturally first the base 1 object will have to be constructed. So, you first that constructor gets called and you get 5 3 as set to the base 1 part of the instance. Then naturally base 2 gets called, you get 0 0 which is a default constructor, that gets set, and finally, the derived class constructor is called, which sets 2 into the whole, into its own data member. Destruction happens in the reverse order as is expected. So, this you can see that except for the order of the base classes, the object construction destruction, the lifetime happens exactly following the same rules as we had for the single inheritance. Okay. So, that lays down the basic properties of multiple inheritance. Now, we will go back and look into the diamond problem. What is the diamond problem? Diamond problem is you have a common base class of your base classes that you are deriving from. So, the question is in the object of the class T A, which person will be taken. So, let us see what happens if you just code this. If we just do not think about anything, just code this part. So, you have a person which has a parameterized constructor, you have derived faculty and student from that, and you derive T A from faculty and student, and just put C out in the constructor, so that you know what is getting constructed. Obviously, faculty will have to get constructed first. For the faculty, person will have to get constructed. So, person gets constructed, faculty gets constructed. Then the student has to get constructed, but the student also has a base class person. So, person is again constructed, student is constructed, T A is constructed. So, you get into a difficult situation that the same T A object has 2 instances of the person object, which certainly is not going to be manageable. Right? This is a semantic contradiction that the diamond problem throws up. So, to avoid that, what we do is we introduce virtual base classes. What is a virtual base class? A virtual base class is one which you want to use for multiple inheritance from, right. Faculty is a virtual, I want faculty to be a virtual base class, because it needs to be used for derivation multiply. Now, when faculty derives from its parent, it uses this keyword virtual. This sense of the virtual is absolutely different from the sense of virtual functions or runtime polymorphism. What this means is, when and you do the same thing for student as well. So, these are the virtual base classes, and you do the same thing. What I have done is I have added a default constructor in person, which I will explain why I did. Now, if I do the construction, faculty will need to construct person. So, person is constructed, faculty is constructed, then the student has to be constructed. Now, what the student sees is it is inheriting from person, but it is virtually inheriting. So, in the context of T A, the compiler will check if an instance of person has already been created. If it has already been created, it will not be created again, the same instance will be used. Unlike the previous case, where 2 separate instances were being used, here the same instance will be used by both faculty and student, which solves the basic problem of multiple base class instances in the derived class object for a diamond configuration, and rest of it is simple. Now, you will have only one instance of T A in the your only one instance of person in your T A object. So, virtual base classes solve that. Naturally, I did that through a parameterized constructor, a default constructor. You can use parameterized constructor also, but if you do that, then your responsibility would be to call that constructor of the root, the person. So, what will that mean? That will construct this by the parameterized constructor, and then the student, then the faculty will be constructed, and the faculty will already find that a person object exists. It is virtually, it is a virtual base class specializing from person. So, once it finds a person, it will not create another person. So, the same person will be used here. but this is the additional that you need to do. If you use parameters in your base class, root class, then you will have to explicitly call that and first create that object, so that that instance, so that that can be subsequently used by the base classes. This is in terms of diamond. There could be other issues to deal with. For example, you have a teach which you override in student and faculty, and in TA, fine, good enough, it will work. What if I do not provide this? So, the question that I leave with you is which of the teach will be used, or how would you resolve that problem, right? So, it's not easy. If you get into diamond, it's not easy to always handle this. Here I leave you with an exercise where I have a multiple inheritance scenario. I am sorry. I have a multiple inheritance scenario where you have a diamond and we have different functions foo and foo bar in the context of these classes, and you have to create the objects A, B, C, D and so on, and create different types of pointers and try to access them to see what kind of function binding you actually can get, right. I have not worked this out for you. We have done it extensively for single inheritance. You should be able to extend that for multiple inheritance. Now, having done this, the question is, does multiple inheritance really solve a huge lot of problems? Here is a simple instance. Well, with this diagram we will possibly not consider it simple, but it is a simple real world. I am talking about vehicles, and I am talking about two dominant properties of vehicles. One certainly is of wheels. We have always talked about 4-wheeler, 3-wheeler, 2-wheeler, and based on that a lot of things differ, price, comfort, licensing and so on and so forth. But what has become very dominant for last couple of decades is how it is fueled. What is the engine type? Is it petrol vehicle, fossil fuel vehicle? Is it manually driven vehicle like a bicycle, or is it an electric vehicle? So, if you try to given these two, now naturally there are several combinations of these properties that can happen. For example, an electric car is a 4-wheeler which is electric. A Toto is a 3-wheeler which is electric. An common auto rickshaw is petrol fueled and is 3-wheeler, right. So, you have a mesh of multiple inheritance happening, which naturally make it a kind of a mess of understanding. So, one way we can look at is this modeling is not very suitable to handle, because for all of these you have to do virtual base class, this, that. So, what we suggest is, when you have this scenario, choose one property which you consider the most dominant property and have a single inheritance structure based on that. Use the other property as a data member, that is as a component. So, engine becomes a component if you create the hierarchy based on the wheels. So, you have wheeled vehicles, 4-wheeler, 3-wheeler, 2-wheeler and different instances, and then each one of them has an engine property or a composition. So, what I am doing is, instead of doing has a for both, is a for both, I am doing is a for wheeled and I am doing has a for the engine component. So, this is a design style which often is used instead of using the complications of multiple inheritance. You can look at this from the other properties perspective also. You can take engine to be your dominant property, because that is deciding laws and what all you can do, electric, fossil fuel, manual, and then have all different vehicles, and in each you can put the wheels, number of wheels as a component and whatever its consequences are. Wheels are just not number of wheels, it has lot of other consequences. So, you can do the inheritance on the engine and use the wheels as composition. So, these are the two ways you can look at decompose the multiple inheritance in terms of composition. It is normally advised that do not try to use multiple inheritance, that really complicates matter in even in a simple situation like this. Use only one dominant property for simple inheritance and use others for your composition purposes. So, we have talked about multiple inheritance and the diamond problem and the solution approaches. They are all different semantics and particularly the design choice between inheritance and composition. Thank you very much for your attention, and we will meet in the next week.